Okay, so we're back here in Dreamweaver, and I have the first chunk of code already typed out for us. You can see that it's the circle over here, and a circle is essentially just an arc. An arc is a curved line, right, that goes around a radius perfectly, and a circle is just an arc that starts in one place and goes full circle all the way back around to where it started. So very simple code here. We just need to understand what the line here, the arc line is. We have begin path and close path like normal. We have context stroke, which gives it the black line so we can see it in our canvas. And then we have this new line here. So context.arc, and then we have parentheses, and then we have 1, 2, 3, three numbers, and then this kind of weird number here, which is 0 asterisk math dot pi, and then another one of those, 2 asterisk math dot pi, and then we have the word false. Okay, so if you're following along in your notes, you'll be able to see what all of these little bits are. I'm going to explain them all. So one thing that you'll notice to begin with is that we have this right here. This is just a note for me. And you can write these notes to yourself in your code as you're working. If you put 3 slashes, you can see that if I delete these, you can see that it's white. But if I come in and just put 3 slashes, the computer understands those slashes to be me telling the computer that these are notes for me, that they're not actually code. So this is a way to mark our chunks of code to tell ourselves what the code is without the computer getting confused and thinking that it's something that we want to execute. Okay, so this is just for us. You can keep your stuff organized really well by using these. Okay. So if you check your notes, you'll see that this line right here, these first 3 numbers are the first 2 numbers are the x and y coordinates of the center point. So the center point of the circle, right? So it would be right in the center here. And that is x and y, so 400, 300, which means that if we come over here and click on our canvas, you can see we go 400 over, 300 down, and that's the exact center of the canvas. Now, you're probably not going to want your sun in the exact center. Maybe you want it over here, maybe you want it up in the corner, up top, or wherever you want it, right? But where you put it is going to be dictated by the center point, the center point of your circle. So that will be dictated by these 2 numbers, which is your x and y of center. The third number here is the radius. By radius, that means the distance from the center point to the edge of the circle in pixels. So this one is 200 pixels wide from center point to edge, which means that it's 400 pixels from edge to edge. You may want your sun to be larger or to be smaller. The way you change that is by changing this number. So if I change that to 100, refresh, you can see that it's a smaller sun. Okay? Let's go back. All right, these next 2 numbers, or whatever you want to call them, are us telling the computer at what point to start drawing the circle and at what point to end the circle. So we can, for instance, draw like a Pac-Man, right, or something along those lines, by telling the computer to start drawing in a certain spot and go all the way till it hits another specific spot, but not to finish it. Okay, and this works off of this right here. So this is a circle, and you don't need to know about all the math behind the word pi and what that is, but pi is a mathematical term, 3.14159 something something something. It's a number that goes on endlessly, right? And all you need to know is that if you think about this as a clock face, we have 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. So at 3 o'clock over here, we have 0 pi and 2 pi. So this whole clock, if you go from one point all the way around, is 2 pi total. Okay, so we start at 0, and then we have 0.5 down here at 6 p.m., 1 pi at 9 p.m., 1.5 at 12 p.m., and then all the way back around to 3 o'clock is 2 pi. So basically, we have 0.5 for every quarter of the clock face. Okay. Now, this is only important so you understand that that we can use these numbers to tell the computer where to start and where to stop drawing our arc. Now, if we're drawing the sun, we're probably going to want a full arc, which is why I did 0 math pi to 2 math pi. And basically what that does is it starts right here at 0, and then it starts drawing, and it starts drawing, and it keeps going until it hits 2 math pi, which is the same exact spot, but all the way around. So it draws a full circle. If we draw from 0 to 1, you can see that it's going to start at 0, and it's going to go all the way around to 1 and stop. Okay, so these are just starting and stopping points. You can see that they're dictated in a very specific way. 0, asterisk, math, dot, pi. Math is capitalized. Pi is, both letters in pi are capitalized, and it's purple. If it's not purple, then you did it wrong somehow. So you want to make sure that it looks exactly like mine. We're going to go back to 2, so we have a full circle here. And then you can say false or you can say true. Now, let's just go back to 1 for a second. Fresh. So where we're at right now is that we have the word false here, and what this reference is, it answers the question, are we drawing counterclockwise? Now what does that mean? So it means that we have a starting point of 0, which is right here, and the computer asks us the question, are we drawing counterclockwise? We say false, which is no, and so that tells the computer to draw it clockwise. So it starts at 0 here, and then it goes clockwise to 1. If we change this to say true, then we're telling the computer to draw clockwise, which means it's going to start at the same point and end at the same point, but it's going to go counterclockwise instead. So it starts at the same point, goes counterclockwise until it hits 1, and then it stops. Okay? So true and false dictates the direction of the draw. Back to our circle here, and that's it. So that's very simply how you would create a circle. Okay, now let's move to our next little chunk of code here. Have all these over here ready to go. We're going to do a quadratic curve. Alright, so this is our quadratic curve. A quadratic curve is a curve that is different from an arc in that we can control the severity of the curve. So if you can look at this one, you can tell obviously this curve is not going to make a circle, right? It's a little too kind of fat and bulbous, and that's what a quadratic curve is. It's a curve that's dictated by 3 points, right? 2 points that are visible, start point and end point. And then a third point that is invisible. And that third point is going to be, the third point of this one is right here. And let's look at the code to begin with. So we have course context begin path, context close path. We have, and then 2 other lines that we already know. Line width of 10, which is 10 pixels, and stroke. And then we have these two lines of kind of new code. The first line is not really that new, but the second one definitely is. So we have context move to 200, 150. So you know that that's XY coordinates. 200, 150 down, there's our start point. Okay. Now if you're looking at your notes, you can see that just next to this line, it says X and Y of start point. So on the notes, it tells you what these lines exactly are. The next line is quadratic curve 2. So we're telling the computer we want to create a quadratic curve, and all 3 of those words are squished together. Quadratic is not capitalized, curve and 2 are capitalized, so make sure you remember that, and they're purple. If they're not purple, then they're not correct. Okay. And then we have 2 sets of coordinates here. So we have set 1 right there is an X and Y, and set 2 is another X and Y. Okay? Now, the numbers right here are the X and Y of our start point. The last 2 numbers are the X and Y of our end point, which means that the middle 2 numbers right here are the X and Y of what we call our control point. And we call it the control point because it really controls what the curve looks like. Now, let's go back to Photoshop here so I can draw it. If we draw a curve, right, so imagine that's a little bit smoother than it is. We have our start point right here, and our end point right here, and then we have this invisible control point. We don't know where it is, but we actually do kind of know where it is based on what I'm going to show you now. So if we take this and we draw kind of this imaginary line between, and then we look at the distance between here and here, we can usually kind of double that distance. So about like that, right? And here is where our imaginary control point is. Basically, if you draw this an imaginary line between the start point and up here, and the other point, right? Then you can see that this line is attached to the center point and is kind of pulling it up. Okay. Now, if I move our control point up, like up way high, what it's going to do is it's going to take this curve and it's going to make it more like this. If I move the control point down, it'll take the curve and make it flatter. Okay, so let's try that. Let's make the curve higher. We're going to take our control point here at 300, 0, and actually let's make it flatter because I don't want to put any negative numbers in here. So we're going to do 300, 100. Whoops. 300, 100, and refresh. And what that's going to do is it's going to push our control point from right here down to about right here, which means that the line is also going to sort of flatten a little bit. And there we go. We can invert the line. So our control point right now is about right here, but if we move the control point down here, it's actually going to make our curve go underneath. Okay, so let's try that. 300, 400. And you can see now that our point, if we imagine this imaginary line right here straight across, and then we look at the distance between here and here, then we can double that distance and makes our control point about right here. So this is maybe a little confusing at the moment, and it will take some time to get used to, of course, but this is the basis for how you're going to draw with quadratic curves. And you could make birds out of this, right? So you do two quadratic curves, and it makes the kind of classic kindergarten sort of M-shaped birds. You can use this to make flowers, to make really anything you want, hills and mountains, that kind of thing. But it's very basic. It works off of a starting point, an ending point, and then a control point. What I would recommend is just put in the numbers that I have in the notes, and then start messing with one set of numbers at a time. So mess with the start point, see how it changes the curve, and then mess with the end point, see how that changes the curve, and then mess with the control point, the invisible one. Always manipulate the visible ones first, and then the invisible ones after. Okay. Let's try Bezier curve. A Bezier curve is a quadratic curve with an extra control point. So it's going to seem more complicated, but you have more opportunity to kind of do weird things with it. All right, let's go back to Photoshop here real quick. And if we think about our Bezier curves, right? Our quadratic curve is something like this, and it has one control point up here somewhere. And that control point is connected to the start point and the end point, okay? The quadratic curve, the Bezier curve, is similar, except for it has two control points. And instead of being locked up here and attached to both the start and the end point, what we're going to do is we're going to have one control point that is attached to the start and one control point that is attached to the end point. And it's going to look more like this. Okay? And if we draw an imaginary middle point in this line, then this handle, this control point, controls one half of the curve, and this one controls the other half of the curve. And so what this allows you to do is get curves that go kind of like this, because you have your middle point here in the middle, and then you have your end point right here, your start point right here, And then you have these control points. So our control point for the end would be somewhere like this. And our control point for the beginning would be something like this. All right. So I know you're probably pretty confused. So let's go look at the code and see what we have. Okay. We have the normal stuff. Begin path, close path. We know what line width and stroke is. So we only really have these things right here. And well, actually, to begin with, let's get rid of this first one. So this is our Bezier curve. We have, just like our quadratic curve, we have a line that says move to, and then an XY coordinate. So right here, 200, 150 is our start point. And then another line that says Bezier curve to. Again, 3 words squished together. Curve and to are capitalized. And then we have 6 numbers here. So this is where you're going to start to get confused, but don't worry, it's not difficult at all. Remember what you know about our coordinates. In the move to line, we have our start point. It's always going to be our start point, okay? The last 2 numbers are always going to be our end point. So there's our end point right there, 400, 150. And then these 4 numbers right here are broken up into, obviously, sets of 2. So the first 2 numbers, if you look at your notes, are the x and y of control point 1. The second set are the x and y of control point 2. And it's very easy to understand which control point modifies which part of the line, because if you'll notice, this set is closest to the end point, which means that this set corresponds to the control point at the end, and these 2 are closest to the start point, which means that they correspond to the first half of the line. Okay? Now, what this means is that right now, you can see the line, how it's drawn. Our first control point is at 150.10, which is about right there. Okay? And that dictates the line between the imaginary center point and the beginning of the line. So watch what happens when I change just this. I'm going to let's move this down, say to 100. All right. So it modified mostly this half of the curve and then very slightly this half of the curve. Now let's do this. Let's try and, well, before we do that, 410 is our second point. So that's right here. Okay? So you can see that now we have a control point here and our other control point at 150, 100, which is about right here. So these are our 2 imaginary control points. I'm going to take this 150, 100 one right here, and I'm going to move it down to here. And what that's going to do is inverse this first half of the curve and give us this kind of S-shaped curve. So how do we do that? We're going to go, let's say 250 and 200 and see how that works. All right, so we're getting started there. I'm gonna modify it a little bit more. I'm going to go 250 here just to exaggerate. All right, and there we go. So this is our S-curve. And now you can see that this control point never moved. It's still at 410 right here. Okay? And this other one is at 250, 250, which is about right there. And you can tell because of where those control points are is dictating the first half and the second half of this curve. All right. There's nothing that's going to make this easy except practice. You're just going to have to get in here, start with the numbers that I gave you, and then sort of modify from there. Okay? The way I would recommend doing modifications is, like I said, start with all of the numbers that I gave you, and then go in, find your start point, because you know that's visible. That's right here. It's always going to be visible. And move it, and see what happens. 250. Oh, okay, that moves it down, right? Start with, and then move your endpoint. Endpoint's always going to be visible, so that's easy to understand where it is. Let's move that down. Oh, okay, that moves that there, right? And then take one of your sets, x and y coordinates of your control points, and start moving it. So I know that my control point's kind of in this weird spot, like right there. So if I want to get that S shape back, I need to move it to more like, I don't know, 300, maybe 350. Let's try that. And there I'm starting to get that S curve back. So you can use this to create really anything. You want to create an animal, maybe it has some kind of S-curve on it, a bunch of other stuff, could be anything. Alright, and then we had this to begin with. And actually, let me show you just the original chunk. This will be a little bit easier to see. Okay, now in the same way we would draw a triangle, we moved to a certain area, then we lined to a spot, and then we just continued to create lines that said line 2, if you remember. And we did that instead of creating a chunk of code for each line. And what that allowed us to do is sort of save us a bunch of work and then connect all those lines. The computer connects them for us. I'm doing the same thing here. So you can see it says connecting Bezier curves, and then in parentheses it says drawing a cloud. So this is a nice way to draw a cloud. You can also do this with quadratic curves. It may be easier with quadratic curves, but I just wanted to show you connecting and how it works. So obviously we know, we just talked about these two lines right here. Start point, right? Start point right here. End point, and then X and Y are the first control point, X and Y are the second control point. Now, if we create another Bezier curve 2, which we've done right here, this is our second curve, you'll notice that we don't have a start point, right? We don't have a move to line. What the computer does is it uses the end point from our last line as the start point for our second line. That makes sense, right? Because we obviously want to connect them. So we're going to want to start our second curve from the end of the first curve. All right, so very simple. You're not going to have to worry about your start point for your second line, and then you just keep going. You have your X and Y coordinates of your first control point, your second control point, and then your last end point. All right, so that's those two curves and circles. The next video is going to show us how to do linear gradients, and then that's it.